How about this one? Looks a little bit intimidating, but obviously we try to see our patterns, and what better place to start from and to see the various components. So we have U on top, and then we have V at the bottom. We see that there's nothing else. Okay. Sometimes you will need to, let's say, change it from a partial fraction, from combined fraction to a partial fraction and things like that. But in this case, we can see that these are individual functions, so we can work with them already, right? So we start with, what is U? U is going to be 4x 3 minus 7x. U, that used to be our fx in the other expression. Okay, then at a bit of distance here, we use v is equal to the bottom part, which is 5x squared plus 2, right? And then we say that we get derivatives here. So here we say du, matter of fact, this time we'll say v prime. Okay, I don't like this, but let's just use proper notation. Du over dx, okay, is equal to that. We know that we're going to use our power rule, and then we have 12x2. Okay, so we should know how this works. This comes and multiplies with that, with the multiple, and then this one reduces. So same thing here, we have 7. What about this side? dv over dx is going to be what? It's going to be 10x plus, this is 0, so we can just end it there. So we should know how to get this. Then we say that they always multiply in this fashion, okay, because that's the difficult part. Then we get the v as our denominator. So again, we should have the habit of making sure that we write the whole formula again. So v du over dx minus u dv over dx. Then we're going to divide by v squared. So meaning that here now, we're going to have v first, which is 5x squared, plus 2. Okay. Then we're going to, because that's v, then du dx is this one. So we're going to have 12x squared minus 7. And minus, like that. We are going to have u is 4x3 minus 7x. And what about dv dx? dv dx is going to be 10x. Then we're going to divide with v squared. V squared is 5x squared plus 2. Right. So now what happens here? What happens is that we need to do the expansions. Okay, so I'll get rid of everything here. Okay, just to create space. Right, so I'll get rid of everything. Then we begin our expansions. So what are our expansions here? I'll expand this, then we'll continue from there. All right, so that's the expansion. So we can see that we take this, we multiply with that. Remember the quadratics, how we factored them. So here with that, and that same one with this one again. So those give us 60x4. This is 60x4. Then that gives us 35x squared. Okay, like that. Then we have this one will give us plus 24x squared. Then that one will give us 14. Then this one is easier because we multiply the 10x with the two factors here. But then there's a negative here, meaning that this one will have a negative 40x squared. And then here we'll have a negative. If I multiply these two, then a positive will give us that. Okay, so it was just to write this down. Right, so we continue. Now, this and that are similar terms, so they can work together. We have 20x4, right? And then this one and that one. And going to give us a negative number, but it will be 11. So that's minus 11x squared. And then we have this one remaining, okay, which is negative 14. And then we have plus 70x squared, right? The same divisor, x squared plus 2 squared, right? Then these two, this one remains like that. So this is 20x4, right? This and that can come together and give us plus 59x squared. then minus 14. Then we maintain our divisor, which is 5x squared plus 2. Then we square it. Okay, so dy dx of that function becomes this one here. Okay, 20x4 plus 59x squared minus 14. Then we have that divisor. Right.